Hi viewer, this is EasyElimu channel. I'm Vincent Kanumai, and today I'll be taking you through chapter 15 of Form 3 Mathematics, Graphical Methods. Welcome. We shall introduce by looking at tables and graphs of given relations. Here we have in graphs, we have different kinds of graphs. You may be given a graph of quadratic equation. Maybe you may be having ax squared plus bx plus c, or you may be given another one in form of you have that containing square root, that you have a into square root of x. You may have others, maybe like a equals to, let's say, a or k a raised to x. These are some of the graphs you may encounter. You will find some which are normal. We know that is mx plus c. And we have also cubic functions or cubic graphs or cubic functions on which you will be required to draw cubic graphs. So on that you may find it is in process of ax cubed plus bx squared plus cx plus d as that. So all this may be, for our case, we shall look up to cubic functions. So all these are given relations of different kinds of functions. So you may be required to draw a graph of that given function. And if you are required to draw a graph, the first thing you should do is to construct a table of the respective function you have. If it is a square function or a quadratic function, you should construct first a table before undergoing to work out or drawing the graphs. The same applies to the other. So today I will start with one and I will give an example among this, and I will tackle this one here. I will take that one there. So I'm going to tackle that of y equals to 3 root of x. And if you have been given a function like that, that is a linear function whereby it is in form of y equals to mx plus c, but here x has been a little bit complicated and c here is equal to 0. So c is not present, it has no y-intercept there, so c is not present. But you will find out that because here we having this square root sign, then the square root will change. That one will not be a linear function. This one here means if you go on and construct, you will find this graph here of y equals to 3 square root of x will give you a curve. That one will not be a straight line or a linear function. So it doesn't lie under linear function. We shall consider that one and work out. So we are going to work out that of 3 root of x. The first thing you should do, if you have been given any kind of a function, you have to construct a respective table to that one. So you will start with choosing the values of x. If you have been given, for example, here we have been given, the values are from 0 is within the range of 0 of that x to 9. And you will find out that if you have that, you will construct a table. The first one is for the value of x, and since it is 3 root of x, the next one here we shall find the root of x, and then the fourth we are going to find y equals to 3 root x. That is what we shall be doing. So what you will do here, you are going to select within this one, you can select whatever you want. For example, the intervals. You may select the intervals if it is 1, 2, 3, or you start with that 0. Then you move on with 1, 2, 3, 4, that way until you find up to 9. I will fill up the table, then we shall work it out. that is what we have. Our function, we were given that, and then from that one the question was construct a table and then draw a graph of this y equals to 3 root of x. After drawing a graph, find y when x equals to 1.6. So that is the question we needed to handle or to tackle there. So after filling the graph, you will find this is the values we will find respective to the respective values of x. That is what you will find, and that of y. So that is how it is. And then on drawing the graph, since we have said that one will come as a curve, let's see. Now on drawing a graph, you will have to have your x-axis and also your y-axis. On graphing, what you do, the first thing, if it is a graph of a given kind, for example, this one here, we said this is a table of y equals to 3 root x. I have named that one. And this one, if it could have a title, then any graph should bear a title if there is one. And if you are drawing some curves or function in a graph, you should name that function after drawing. For this one, we shall label the axis which we have. After labeling and then you select your interval which you want to use. For example, you will identify for y is from 0 to 9, and that is of x is from 0 again to 9. So you can select any working interval. For my case, I selected an interval of 0 to that way, 4, 6, 8, 10, 12, that way. The same to this one apply, 2, 4. Now, the purpose is that on drawing you will find both x and y are originated from 0. So meaning the first point of that graph will be here. And on drawing that graph, you will find it is a curve from the origin. As it goes up, it will be curving up in this manner. You will draw it and you will find out what you have. For I did one of it, I have drawn it on a paper, and this is what I found. Now on drawing that graph, you will find your graph will resemble what I have here, a graph of y equals to 3 root of x. So what we are going to have, you will have that graph will be originating from the origin, which is 0, 0, as per the points which you will have, and then from there you will find it curves as it moves upside. So after drawing using the points which we have given out for the respective values of x, you will find, if you want to find x equals to 1.6 and find the value of y, then you will evaluate where x equals to 1.6, and for my case was here, as you can see. From that point, then you move up to the point where you will intersect with the curve. After that point, you move to y-axis and see what value coincides with the point where you intersect with 1.6 with the curve. So that is how we do that, and on drawing the graph. Now, we have seen how we can obtain the value of x equals to 1.6 and obtain the value of corresponding y. So if that is the case, from the graph, you will find that one is approximate to here. And if you move up, you will find from the graph which I have drawn, it will give you 3.8. And that is what we have seen from that graph. So that is how we do work some of them. This was just a sample of some of the given relations which are related to graphs and tables. But there are several of them. So you can select one, but remember to construct a table before drawing the graph. A table is useful in that it will help you to construct a given graph. So given function, to construct the graph of a given function. So that is how we do that. And next we are going to see how to solve a cubic equation on graph. That is graphical solution of cubic equations. Let's see how we can find solution to cubic equations using graphical method. So under that, we know one thing, that if you may encounter any of the expression written in this kind, then know that that expression is a cubic expression where the highest power you can obtain in the variables is 3. It's only 3. That's the highest power you can obtain. And as you can see, we are having some of the variables that is x, but they are given order of power. So this one is to power 1, this is power 2, this is power 3. If you find any function having up to power 3, may it be with another different variable, it may not be necessarily x, it may be represented by any kind of letter, so that one will be referred to as a cubic function. But remember, in this one, here a, b, c are coefficients of x and also d, but all of them are constant, meaning that a, b, c and d are constant. So from this is where we can obtain. Now if you find another function like this, no, this one here is a cubic equation and this one is a cubic expression. That's the two different. This one is equated to something, that is to y, and this one is just an expression. So the two are differentiated that way. So the same applies. Here we have two variables, that is y, which depends on x, and x is a variable which has up to power 3 as the highest power, and here a, b, c and d are constant. So we can find some of the cubic expression, like you may have 4x cubed plus 2x squared plus 5x plus 1. That is one of them. We have x cubed minus 7x plus 6. You may even have another one like x cubed. There are several of them. So we shall consider now the solution of cubic equation using graphs or using graphical method. And the solution of cubic equation using graphs, you will find that you may be issued with one of graph like y equals to ax cubed plus bx squared plus cx plus d, and you'll be asked to draw the respective graph according to this. What do? The first thing, remember, you have to form a table. And that table will be, you select the values of x. If you have been given a range, you use that range which you have been provided with. If the range is not provided, then you use your own, which you know it is certain that will give you the best result you want. So you will select the ranges of x, and then from there you will construct that of ax cubed. You find that of bx squared, cx, and then d, and also that is plus d. So, and then you will come and find that of y equals to ax cubed plus bx squared plus cx plus d. Then you will find out if you add that, this one here is found by taking as they go down. If it is positive, they will be in that direction. So if this one also, if here is negative, then here the sign will change and be negative. We include their signs. So that is how we do work out. If it is positive, it will remain to be positive as it is. So with that, we can solve by constructing a table. So I'm quite sure that if given a cubic function, you can construct a table to that cubic function. After that, you now use the values of the variable x and the corresponding values of y to construct the table. After constructing the table, they may not be necessarily x and y. Sometimes they may change and give you some different kind of letters. But remember, that is what you will be using to construct your graph. So after construction of graph, you may be given another kind of cubic function. For example, this one you may be now told construct with ax cubed plus bx squared plus cx plus d equals to 0. Now you are given this kind of cubic function. After constructing the graph, they are telling you to use that one to give or to solve this kind of equation. To solve this now from this perspective, you are now required to take y equals to that ax cubed plus bx squared plus cx plus d, and you subtract that equation there. So you will start with 0 is equal to now fx cubed plus bx squared plus cx plus d, and you will find out that for this one here you will have y equals to 0. Sometimes it may be y equals to a given number, which will be a y-intercept. So if it is a y-intercept, remember all the lines of y-intercept are parallel to x-axis. So you will draw that one and find out where that line cuts that given curve. If it cuts at 3 given points, that points are the one which you will give it out. So that is how we do it out. Sometimes you may be given that the same cubic function, but on solving, here we are subtracting. On solving by subtracting, you will find here you are now getting a linear function. In that you will have, for example, you may have even cx plus k, let's say just that way. So if you have cx plus k, now you will construct this. You may construct the table of this, or you may just construct, because this one is a little bit easier. So you will be required to construct this line on that graph. So this is a linear function, and on construction on a graph, it will give you a straight line. So that straight line will still cut the x, and will still cut your curve. The point where the straight line cuts the curve is the solution of that given equation and this one. So you give that given points. So that is how we do. And in case you find this y equals to cx plus k, you will find the point where it cuts, it is having two values. That is a value of y and x. So meaning it may be a, b. You may find another one may be like CD, and another one like EF. So because it's a cubic function, you will find it cutting at 3 points, and you will have that kind of given values. These values which I'm giving as letters will be real values, like 5, 4 given. That is the point where you will find that line cutting your curve. So that is the point where you will take that value. Now, the solution will be these x values. So that one is the one which will give us the solution. So that is how we do work it. So let's see an example and see how we can enumerate much more of what we are talking about. We have been issued with a cubic function y equals to 2x cubed minus 3x squared minus 3x plus 2. And that one we have been told to construct a graph with intervals -3 equals or less than x, which is equal or less than 4. That is the interval which we are being given or provided with. So from that one, the first thing you can see here, I've constructed a table, and this table here you can see each variable here, each term here is actually treated individual, as you can see, for easy perfection. That is to avoid the wrongs which may arise or errors. So that is how you do construct that table, and on constructing you will find that the corresponding values of x are here, and that of y are on the denominator or the lowest part of the graph. So that is how is it. And on graph, what you will be plotting is not this against the values here. You will be plotting the values of x with the corresponding values of y. If it is -3, then it will be -70, -2, -26. That is how you do plot. I think you understand. So on plotting that graph, you will find that the graph appears in this section. the graph will appear to move from downward part, then moves that way. The graph appears that way. That is how I view mine was in that case, so we can view it here. And from that graph, you will be required to do something. So the graph is here actually. So we have a graph of y equals to 2x cubed minus 3x squared minus 3x plus 2. I have named it. And the graph, you can see the curve I have given it. From what we have there as the values on the whiteboard, we have the graph starts from y equals to negative 70 and rises up to y equals to positive 70 up there. So that is what we are having. And it coils twice, cutting the x-axis thrice. At this point here, another one at the other point, and another one at that point. So if you are being asked to give the solutions of this graph here, then it will be the point where the graph or the curve cuts the x-axis. So it will be equal to, at this point here, as you can see, it is at negative 1, then positive a half, and then again at positive 2. So those three values, as you can see, I have indicated here, are the values where the graph will give the solutions of that x. So that's the cubic solutions of that variable x. That's how we do find it. Now the question goes on and asks more, says, now after plotting the graph, I have solved 2x cubed minus 3x squared minus 3x plus 2 equals to 0. That is what we have here. So we have been issued with this equation here. So we have been asked, using whatever we used to draw a graph, this equation here, we should solve this one using the graph. So in that case, what you do, remember all the tips I gave you earlier. So what you are just doing, you are just revising this, and you say this one is equal to 2x cubed minus 3x squared minus 3x plus 2 is equal to y. So you are going to subtract in order to find what is there. So you will find this equation here is identical to this equation. So meaning if you subtract, you're going to get 0 is equal to y. So you are going to draw a line of y is equal to 0. And the line of y is equal to 0 actually is the x-axis. So the values which we found are the solution of this given cubic function are still the same solution to this given equation. So meaning it will have x equals to negative 1, x equals to a half, and x equals to 2. These are the values of that equation. So with that, I believe that if you have been given with any equation involving cubic function or quadratic function, you can draw them on a graph, especially cubic function, and you'll be issued with other kind of cubic function. You use whatever you do on the graph to solve. So I believe you can work it out. You may sometimes subtract and you find whatever you will get here is a linear function. Use the instruction I gave you earlier and give your answer or find your answer respectively. Now let's go on and find the average rate of change. And under this we are going to consider two ways. One where we have a curve and another one where we have a linear function. So we shall consider a graph. Let's consider these two graphs. One of the graph here is of a given particle moving at a given, actually covering a given distance. This one is distance in meters with given time in seconds. And then we have another graph here which is a curve and is of a height of a growing seedling. So that is a height of growing seedling in centimeter with respect actually to number of days. So that is how it will be. So let's start with this one here, and we shall find out that if that particle is moving, you will find this, if this is the distance to be covered, in only 1 second, it will have covered approximately of 30. So in 1 second alone, the particle will have covered 30 meters. So as you go on, as you move, you will find it's going on as it undergoes coverage. You will find that in 1 second, the particle covers 30 meters. In 2 seconds, it is covering 50 meters, and in 3 seconds, it is covering 70 meters. So meaning that if you find the gradient of this graph here, the gradient, for example, let's take these points here and here, you will find that the change in y or change in x will be equal to 50 minus 30 over the change in time will be 2 minus 1, so it will be 1, and you are going to find that it will be 20 meters per second. So meaning that the gradient here, or the rate of change, is 20 meters per second. But you will find in 1 minute is 30 meters per second, and in 2 it will be 50 divided by 2, you will get 25, and in 3 seconds it will be 70 divided by 3, and you're going to get 70 over 3 meters per second. So you are finding that at each time or second, we are having different kind of speed. But you will find the constant of the speed, we are having it as 20 meters per second. That is what we are referring to as average rate of change. So it is constant throughout, but at some time, you will find some graphs will not give you the average rate of change to be constant. They will vary from one point to another. For instance, let's observe here. We may select 2 points. In finding average rate of change in a curve, we do select 2 points, and then we construct it such that if we find the tangent to that chord joining the 2 points together, that is our average or rate of change. So we can select the first point like here, and we call that point like point P. Select another one, call that one Q. And if we find the rate of change here, though it may look like it's a straight line, but if you construct it, you will find it's not a straight line. So you will find it is having a steep slope, but it's not a straight line. So we shall find the rate of change between the 2 points, that is P and Q. Now if we want to find the rate of change for that seedling, let's say the 2 points be, one is between the 1 day and 3 days. So that is between 1 day and 3 days. 1 and 3 days. So meaning there's an interval of 2 days within. So if that is the case, we shall find the rate of change between those 2 days and find out how long did that seedling grow up per day. So we are going to take, if you are being asked that way, remember, you are going to take the 2 points, then you find the rate of change them. So we are going to find here, what is there, you will find it is, actually the coordinate of that one will be equal to 7.5, approximately 7.5, and here we are going to have 3.5. So meaning that that one will be 7.5 minus 3.5, because we are finding change in height over change in time. So we shall have 7.5 minus 3.5, and then the respective number of days, that is 3 minus 1. So we shall have 2. And here we are going to have 7.5 minus 3.5, you will get that is 4. Divided by 3 minus 1, you are going to get 2. So you will get, it is 2 days, actually it's 2 centimeters because we started with this. So this one is in centimeters. This is in days. So it will be equal to 2 centimeters per day. So we shall find that between point P and Q, the seedling grew with 2 centimeters per day. That was the average rate of change between point P and Q. Now let's introduce another point in that how long, actually we want to see how long in height did it change or grew in the next 2 days. So in the next 2 days, we shall add from 3, we add 2 days, so we shall find 5. And if we move 5 up to obtain at what rate will it be, so we shall have, we are going to have approximately 2, let's just say 9. So if we have that one approximately to 9, so we shall have rate of change in height, or rate, actually the rate of change will be equal to that of change in 9 minus that of 3. The hour of 3, that is 7.5, over, now the other one is 5 minus 3. So it's actually just 2 days. So you will find this one is going to give you 1.5 over 2. So on working out, you will arrive at 0. This one will give you 7.5 centimeter per day. As you can view out, between P and Q, let this one be R. Between P and Q, we had a rate of change, average rate of change of 2 centimeter per day. But as we moved on, you will find that the rate of change, the average rate of change is changing, because this one here is a curve. And from there we can find the next is 0.75 centimeter per day for the next 2 days. So they are totally different. So they are not constant as it is in a linear function or a linear graph. So that is how we do calculate. If you are being asked to find the average rate of change in a linear graph or a linear function, you do find the gradient of that graph. But if it is in terms of a curve, you find the 2 points which you are being allocated, or you find 2 points by yourself. Then you find the average rate of change within those 2 points as we have been working out. So like here you will find that you will have a chord connecting the two, and then we have that one. So that's what we do. After that you will have found the average rate of change of that point. So what we are going to start next is, what if in case we are told to find the rate of change at instant point, at an instant point. So that one we shall view it here. If you have been asked to find the rate of a change at instant point, what we do work out is that you will identify the point which you have been provided with. For example, if it is, for example, this one we have been told is the decaying, is actually decaying of sodium, and this one is period of time. So that is mass, and this one is time. Time, let's say in years. Maybe in years. So decaying may be that way, and this one is mass in grams. Just let's say mass in grams. So that is the decaying. So you may be told, find the rate of change at t equals to 4. So at t equals to 4, that is at instant point. There are no 2 points. If there were 2, we could find the average rate of change. But here, because it is only 1, we shall find the rate of change at that only 1 point there, 4. So to find the rate of change at instant point, the first thing you need to do, you have to draw a tangent at that given point. After drawing a tangent, then you will find the gradient of that tangent. if you find the gradient of that tangent, you will have found the rate of change at that given point. Meaning that the gradient you will obtain is the value of the rate of change to that given particular point. So, constructing a tangent, I think you understand how it is. You can construct like that, and then you take at any specific point. But remember, the closer you take the points, the more accurate you will be. So you can select them as like at point here. And just take up to this point here. So if you take up to that point, you will have 5, 3 in the x, and in the y you are going to have so you will have 3 point approximately 8 and 2. So we are going to have 3.8 minus 2 over, in time here we shall now have, as according to what we have found, so we are finding the gradient of the tangent. So that will be 5 minus 3. So we shall have 3.8 minus 2, you are going to get 1.8. So it will be over 2, and you are going to get, this one will give you 0.9, and it is 0.9 grams per year. Because this time here we have been told is in years, and this one is decaying mass of sodium in grams. So that is how you do give it out. My point is, I wanted you to see how to calculate the rate of change at instant point, in that you construct a tangent to that point where you have been asked, and then you find the gradient of that tangent. You will have found the rate of change at that point. So we shall see one of the examples. And the example reads, draw the graph of y equals to 5x cubed minus 15x plus 7 for negative 2 less than x less than 2. So the interval is from negative 2 to positive 2. Find the gradient to the curve at the following point. One is x equals to 1.25, and another one is x equals to 1. And also we have that one. So the first thing there is to draw the table of that given function, and that is what I did. Now on drawing the graph, I found the graph appears in this direction. So it is like a letter N graph. That is the graph of y equals to 5x cubed minus 15x plus 7. So if you are being asked to find the rate of change at point x equals to 1.25, then it is at this point here. From x here 1, so you will move another additional of 0.25, so I found it at this point. So if I construct a tangent to that point, I'm getting the tangent will pass at that point in that case, and I may take any 2 points on the tangent. That is, either I select at this point and the other. So I selected at 20, which is at maximum here, and another one at 5, which is at lower but not the other point. So it is at lower point, which is 5 here. So on doing that, I'm getting 20 minus 5 over 3.7 minus 2, and I'm getting the gradient of that point at that tangent is 15 over 1.7. I think you can simplify further, and at x equals to 1, you are having it as in this point, and you will find that at that point is where the graph makes a turning point. The curve is making a turning point at that point. So if you draw a tangent at that point, will be horizontal and it will be parallel to x-axis. If that is the case, you will find that your gradient to that point will be equal to 0. So meaning that the average rate of change, actually not the average but the instant rate of change at instant that place or that particular point will be equal to 0, but the other one will be 15 over 1.7, and that is what we do refer to as the rate of change at instant point. In general, we can say that if you have been asked to find the instant rate of change at instant point or a particular point, if you construct a gradient of a tangent at that point, will be the rate of change at that given particular point. Now let's view empirical graphs. And under empirical graphs, we will find out that as you go on to collect some data from respective experimental events you will have done or observation made from the field, you will find that that raw data will have some errors. When you use them to construct given kind of graphs, you will find that they are having some of the points which may miss from the line or where you want to construct it. For example, you may be given that a certain school or a certain group of people may have gone to collect given kind of temperature, how it varies with the given length of a metal rod. And in that we have a given table here. For example, we shall consider a given example. Now this one here, as we have here, is a graph. Actually, it's a table showing L centimeter of a metal rod, how it varies with T degrees Celsius temperature. So as we can see here, so if you use this data to construct, this one is raw data from the experiment being done, and if you use it to construct a graph, you will find there is a certain appearance which will be abnormal according to normal graphs. This one will occur to give us some different kind of results, so that in case you plot these graphs, you will find out that you are going to have some of the points which will be outside of the line which you want to construct, or outside the sum of space which you want to work out with. So you will find some of the points here, you will find they are always lying outside the field which you are constructing. So in order to join them, you have to use another technique. And if you construct those points on a graph, you will find that as you construct the point, they will give you a certain pattern, whereby that pattern will direct you which kind of graph will you draw. If it's a linear pattern, you will find they are always lying or demonstrating on a straight, almost a straight line, so that you may have something like, you will find that if this one is like, let's say T degrees Celsius, and this one we have as L centimeters, that is the length in L centimeters. So you will find, in case we have that one, of course the length of that metal rod may be starting at this point, for example. So you will find you are having some points which are going from, that is from maybe negative, that is from 4, so you will be 4, 4.7, 4.3, I mean, so 4.3, 4.7, 4.3, 4.7, you may go that way, then you will have another one going that way. It's not actually straight into line as you may have done it. So you will find the points are displaying that way. So from the way the point emerges out, it will give you certain that the kind of graph you will draw is a linear functional graph. So from there, what you will just do is to find the line which possibly covers or passes through the most of the points. So if that is the case, you will find that that line is what we do refer to as the line of the best fit. So you draw and find that if you are joining them, you will find out whatever you draw should pass in most of the points, in that you are going to have equal distribution of the points. If you miss some of the points, there should be equal distribution on either of the side. If it is downside side, we can find, like for this one here, I'm having 3 points which I haven't passed. That is 3 points. For that case, we're having 3 points. And the upper side, I'm also having 3 points which I haven't, which line did pass through. So in that case, we have managed to make a line of the best fit since it is covering 5 points. That is most of the points, and 3 points are outside on the either sides of the line. So that is the line of the best fit. So from the graph here, as you can see here, I plotted some of the points. So from the data we have, if you plot that points, you will find that the graph will start at point 4. So meaning that is our y-intercept here. So the graph starts at that point and then it's moved throughout. So you are finding that some of the points are outside, like here we have one of the point out here, another one on the down here, another one up, another one down. So you are finding some points are out of that line of the best fit. The line must pass through the most of the points, and you can find, if we want to construct that one and give the relationship, this is how we do construct. And the relationship shall be given from whatever we are seeing here. We need to find the gradient of this line. After finding the gradient of this line and use this y-intercept, we shall give the relationship between L and T. So let's see how we can give that one. So from what we have, we've found that the graph will pass through this point here, as we have there. So that 4 there is our y-intercept, but the coordinates of that one is 0, 4. And also we can find out that the graph there, from what we have constructed, this is a sketch. So from what we have constructed, we have seen from there, you will find that that graph passes very clearly through point 5,5. And that 5,5, then we shall have that coordinate 5.5. So that is 5.5. That's the coordinate now which the graph passes clearly through. And also it passes through point 4, 0, 4. That is 0, 4 and 5.5. So we can still find out the gradient of that graph. And if you want the gradient of that graph, then if we assume that this is the point where I'm mentioning, then we can find the gradient by taking the change in L over change in T. So if that is the case, we shall say that if we find the change in L, which is the length of the metal rod, so will be given by 5.5 minus 4 over change in L, we are going to have as 5 minus 0. So you are going to have this one as, here denominator will be 5. On top you are going to have 1.5. So if you go further to divide, you are going to get, this one is going to give you 0.3. So meaning that our gradient here, the gradient of this line here is 0.3. So that is what we do find as the gradient of that line. So it is 0.3 centimeters per degrees Celsius. That is the unit for that, because it is in centimeters. The metal rod is in centimeters, and that is in degrees Celsius. The graph shows that way. So that is what we shall have. And having that, then we can give the linear relationship between L and T. And since we have said y-intercept, we have found that that graph cuts y-axis at 4, and the gradient here we have found the gradient is equal to 0.3. Then we can say that our equation there, we can write it in form of y equals to mx plus c, whereby our y is now replaced by n, and our x is replaced by t. This is t degrees Celsius. So it is t, that is temperature. And c-intercept, this c here is normally the y-intercept, and that is we have here as 4. And m here is given as the gradient, and gradient here we have as 0.3. So we can confidently say that the linear relationship between L and T is that L is equal to 0.3 T plus 0.4. So that is how we can give it out. So in empirical graphs, the main issue is that you have first to draw or to plot the points, then the plots, the emerging plots that you have given or written down on a graph will give you the design in which your graph will look like. So after that, construct, if it is a linear function, construct a line of best fit. But if it is a curve, then you will find the line of the curve of the best fit also will appear. So you will construct it again and find out the respective problems associated with that graph. So that is how we can do, and that is how we have done for this section. So next we are going to see reduction of those non-linear equation to linear. Remember in chapter 9, we did learn about formula and variation, and I remember under inverse variation, we did say that if you have a graph in that you want to plot a graph of k over, for example, w, or plot y equals to 1 over w, you will find this one will give you a straight line. But the same graph, if you plot y against w, you will find is a curve. So meaning that this here which you have as y against w, in case of this, you will have that one will give you a curve, and to avoid that we need to reduce it to linear form, and reducing it to linear form you will find for that case will be in that category. So for this case we are going to have some of them, and you may be given a relation in which you have y equals to, for example, kx raised to n. You need, in order to graph this, you need first to reduce it to linear form in order to find the values of respective variables, and then you plot them on a graph. So for this one to be reduced in linear form, you shall introduce log on both sides such that you will have log y is equal to, remember the law of logarithm, further logarithm, what we did? We said if you have the two and you are introducing log to the base, to the same base, then we shall have addition, and it will be log of k plus log of x raised to n, but it's the same as writing n log of x. That is how we do write this one in linear form. And if you have been provided with either y or n, you can now find out what you want to find. So we shall go on and find. And this one here you may be having wy is equals to k. So reducing to linear is thus you divide both sides by w. So you will find you're going to plot y, a graph of y equals to 1 over w. This one will be a straight line, and here this graph here will be a straight line. So that is how we do reduce them to linear form if they are non-linear. So we shall see an example. We have been given that if given a relation between A and R is, we have a table where R ranges from 1, 2, 3, and 4, 5. So we have 3.1. A is 3.1 for R1. 2 for R2 is 12.6. I will draw the table. So it is suspected that the relation of the form A equals to KR squared. By drawing a suitable graph, verify the law connecting A and R. So we need to verify that law and determine the value of K. So from there we need to do that. So let's see how we will work it out. Now we have been given a table where we have R and A, and from there we have been issued that if you have those values, that the relation is suspected that A is equal to KR squared. So we need to plot that graph of A equals to KR squared, where it resembles Y equals to M. It will be just of MX plus C, but now here C will be absent. C is absent, so we shall have, actually, if you consider another way, it should be a quadratic equation. But if you plot this graph here, you will find the graph is going to give you a straight line through the origin. So if you plot the graph, it's going to give you A is given us below, so we shall just translate it that way. And then K will be our gradient after working out. So we are going to square R. So that's why I made this table here. And on making the table, you find these are the values. So meaning that we are going to plot A against R. And that is what I shall plot here. And you will find the graph will look like this. I would like you to help me make one of it. This one you will work it out. So you're going to construct a graph of A against R squared and see the relationship. And then after constructing, find out the gradient of that graph. And you will find out that the gradient of the graph will be equal to, like, taking two of the points which the graph passes through. So it may be 12.6 and 3.1 and 2.1. And you should find that the gradient of that line is equal to, that's changing A over changing R squared, should give you actually 3.1. Let's just take to one decimal place. So it will be 3.1 decimal place. So if that is the case, now we have understood that if you work out the graph, you will find out the gradient will be 3.1. But remember, we have said from A equals to K R squared, here K is our gradient. So meaning that the value of K is equal to 3.1. And if we were provided with units, then we could give the units. But here we shall just give K equals to 3.1 to 1 decimal place. So that is how we can construct that. Here we were given the linear relationship between A and R, so we had no reason of seeking it. So we shall go on and find out another example. From 1960 onwards, the population of a certain town is believed to obey a law of the form P equals to KAT squared. So the question reads, of example 2, from 1960 onwards, the population of P, or the population of a certain town, P, is believed to obey a law of the form P equals to K A raised to T, where K and A are constants, and T is the time in years recovered from 1960. So we shall have that graph there. We have a graph of T and that of A. So it's a table of T and A. So we are going to have by plotting a suitable graph, check whether the population growth obeys the given law. Use the graph to estimate the value of A. Now, to work out that, what we need here, students, we just need to use the law of logarithm in order to find what we don't have. For example, in this case, this one here we need to change it because it is already in nonlinear. It's a nonlinear law. We need to change it to linear law form in order to construct a graph that involves this. So to change it, we shall introduce log to both sides such that we shall have log P is equal to log of K A raised to T. But remember, if you have that one, it's the same as writing log P is equal to log of K plus, because the law of multiplication, we said if we introduce log, separation will be addition. So it will be, now this one is log A raised to T, but this one here we said is the same as writing T here t log a. So meaning that we are going to have log p is equal to log k plus log a t. So as we can see now, this one here is a linear equation because we are having this variable p and we are having here a constant. We are having another constant log a and t will be our variable because this one is in the form y is equal to c plus mx, where c is log k and m is log a, t is now x. So that's how it will be. So we need to convert this one to be in form of linear, and to do that we are going to introduce a table. So we have seen this one, if it is in a linear form, it will be log p is equal to log k plus t log a, or log a t. So this one should not be a, it should be p, that's population. So if that is the case, we are going to introduce log. I'm going to introduce here log p from there. So we shall introduce log p, then we construct or we plot a graph of log p against the time in years, which will be t. So let's give out and see. Now I have already constructed a graph including t and log p. So we said we shall plot t, or we shall plot log p against t because log p is resembling here. We shall take that one as y and t as x. So log a will be the gradient of that graph, and you will see that this graph will have a straight line passing through the origin or the given vertex. If we have log k, then this log k will be the y-intercept. So in that case, if it is present, then it will be passing through log k as the y-intercept, and log a will be the gradient of that linear function. So here we have a graph. So you will find out that on plotting log p against t, or time in years, this is what the graph we shall be having. So you will find the graph is a straight line from 3.7, which I just estimated to 3.7, but the real value is 3.869 at that point, 3.699 I mean. So you will find the graph passes that way. So after plotting, you are going to have it in that kind. So if you find the gradient of that graph, the gradient of the graph will be change in log p over change in time. And if you find change in log p over change in time, at this I took this section here, and you will find the change in interval is 5 years. So meaning it is 1970 minus 1965, and change in y will be 3.90, which if you take it from the graph, it is 3.869 minus 3.784, and you will find change in p over change in t, or the gradient of the graph, is 0.017. From there we can also notice that the y-intercept, which we refer to as log k, is equal to 3.70, which is, as the value given, will be 3.699. So from there we can calculate out and find the real value of A and real value of K. So let's see. From what we have found from the graph, this is the values of the respective constants. So we shall find K, and to find K we are going to find antilog of 3.699. So the antilog of that one will give us 4,898. So meaning that that will be our constant, and A if you find the antilog of A, it will give you 1.04. So you will get is 1.04. So meaning that we can give out the relationship here as we have here as P is equal to, now the value of K we have found, so we can represent K as 4898. So P will be 4898. And then in bracket we are going to have 104, that is the value of n, then we raise to t. Now this is the linear, that is now the nonlinear law, that is the relationship we are having here. But if we are having this kind, here will be log k, we are going to replace it with 3.699, and here log a shall be 0.017, and then t will remain that way. So that is how we do evaluate it out. And in general, we can say that if you have been given a law which is in form of, actually we have seen it, KAX, then if this is the law where K and A are constant, then we can write this one as log of y. We introduce logarithm to both sides, and you will find is log of y is equal to log of k plus x log of a. That is how we do write that one in case you have been given that, where x is variable but the power of the other expression. So otherwise, you may be given y equals to kx raised to n, where now n is a constant and k is also a constant. So here still you will get it as log y is equal to log k plus n log x. But here what will change is this. In this case here, you will be plotting log y against x, and then log a will be the gradient of that graph or that linear function you will find, and log k will be the y-intercept. But for this case here, you will be plotting log y against log x, because x now there is a variable, and n will be the gradient of that function, where log k here will be the y-intercept. So with that, we have seen how we can reduce nonlinear laws to linear forms and form graphs of the respective relations. So we have seen. Next we shall see how to find equation of a circle. We are going to start with equation of a circle. Under a circle, we shall draw a circle here, either on this plain paper or using a graph or in a graphical method. We still give you the same thing. So what we are interested in is studying how to find the equation of that circle. In that case, I will draw a circle here. That is a circle which I have drawn there. So in that circle, we shall assume that if this is the center, we assume that it touches one of the points, let's say point P, there, point P. And this circle be having center O with origin or in case it is drawn to a graph. If you draw it on a Cartesian plane, this center here should be at the point where the axes meet. And this radius here is 3 units from the center of that circle. So meaning that this point P here which we select, it will have coordinate x and y. In that case, we shall find out that if you do that, we can extend this out and find, in case we want that to be another radius in that direction, that is to x-axis actually, we shall find out that if this one is x-axis, we can draw a perpendicular from that P to meet there, such that we shall have this line where they intersect as, let's say, n. If we have that, we know from what we can see there, that is a right angle triangle. And this one will be angle theta, which we don't know for this time. But here we know we have 3 units. The radius is 3 unit. So from there, we can still find the equation of the circle, but before that, we know from Pythagoras theorem we do know that if we take ON squared, we add to NP squared, we should get OP squared. That is a rule from Pythagoras theorem. And remember, this P is from x-axis to y to in the y direction is displaced y. It is displaced y. And then from the center of origin O to point N, you will cover a distance of x, as you can see. So the coordinate gives the distance from that center of that circle. So meaning that x will be the distance from O to N, and also from O to P, where we have as y, of which will be represented or transverse to this point here, is the same as y. So in that case, we can say Pn, we're having Pn or Np as y, and On or No as x. So in that case, we can substitute and say that On here we are having as x, so it will be x squared. Np or Pn we shall have as y, so this one should give us 3 squared. This is only for a circle which has a center of origin as 0, 0. Center of origin or the center of that circle is the origin, so that is 0, 0. And we see whatever we have found here is what we shall refer to as equation of that circle. So meaning that if you take x squared plus y squared, it should give us 3 squared from this. This is what we shall have as the equation of the circle. In general, if we have that one in that case, then it will be that if this is R, we shall have, and we have point P, then the equation of circle will be given by x squared plus y squared equals to r squared, where the center is of 0, 0 coordinate. Let's go on and find where the center is not of 0, 0. So let's go and find the equation of that circle. Let's consider we have a circle like this, and this still be our point P, that is x, y, and here be point N. This one still remains O as the center of that circle, but here is 5, 4, B5, 4. So you are being asked to find the equation of the circle if the center is not 0, 0, is now 5, 4. So in that case, we shall still have the same in that the distance from O to N will now be, since we have from O to N, we have x distance, so or x is the coordinate of finding P at this point, so meaning it's the displacement in x-axis. If that is the case, to find the distance from O to N, we shall take x minus 5. That is the distance from O to N. The same applies the distance from N to P, which will be the same as being displaying from this in vertical direction. So that is in vertical direction will give us, this one is the distance of ON, and that of NP or PN will be equal to, that is, since it is 4, it will be now, you take, actually should be y minus 4. So if you take y, the coordinate which is now for P, minus 4, you will get the distance or the unit which is of measure from O to, actually from N to P. That is in y direction, and if it is in x direction, that is how we do. So we have that. So meaning we can still find the equation of the circle if we have the radius r, as radius being r units. So in that case, we shall have this one as ON still the same, ON squared, so we will have ON squared plus np squared, and this one is going to give us OP squared. Since triangle ONP is a right angle triangle, so we will use Pythagoras theorem. Doing that, we are going to have ON is x minus 5 and NP, so this one will be squared, NP is y minus 4. So we are going to square again, and OP we are having as R, so it will be R squared. So on doing that, that is what we shall have as the equation of a circle where the center is not the origin, meaning the center is not 0, 0. So if you are being issued with the center there, that is how you will find the equation of a circle. In case you have, in general, let's just say in general, in case now the center is given in terms of A and B. If it is in terms of A and B, how do you find the equation of a circle? You will find that it will be the same as replacing the coefficients of now there A, which is 5, and that of B, which is 4. So if A is positive, then we shall subtract, we shall just replace that one will be x minus A plus y minus B is equal to R squared. And this is the general equation of a circle, where the center is not the original 0, 0, where just you have some values being given out like that. If the values are negative, you will find this sign will change to positive because you will substitute with the sign. It will change to positive. Now let's see some of the examples and how we can find some equation of the circle from some problems involving equations of a circle. We have been told, find the equation of a circle passing through points 3, 4 and has center 0, 0. So there we shall use the same. So here we need to find the radius. After finding the radius there, then we find the equation of that circle. So the first thing we need to recognize is that from 0, let's say this one is N, this one is P, and this is O. Then from 0 to N, we will have covered 3 units because of the 3 in coordinates. So you take 3 minus 0, you will get is 3 units here. So meaning ON is 3 and NP will now be 4. If you want to find OP, then OP will be determined by taking ON squared, actually the square root of ON squared plus that of NP squared. If that is the case, you are going to have ON squared will be 3 squared plus NP here we are having 4 squared. So all of these are under square root sign, and this one you are going to get is 9 plus 16, and 9 plus 16 you will get is 25. So on finding the square root of 25, you are going to get that OP is equal to 5. So OP will be 5 units. Now OP we have found is 5 units, and this OP is our radius, our radius. So if that is the case, we shall now find the equation of that circle, and we shall replace the value of P by, or we just let another point to be that we have another point like, let's say Q, such that we have that way, or we replace just what we have there P, instead of those coordinates we replace, we say let it be x, y, in order to find the equation which is bound to that circle. In that case, it will be, we shall take that x minus 0, you will just guess x, so meaning that it will assume the relationship of an equation of a circle with the center of a circle being the origin. So meaning it will take the form x squared plus y squared is equal to r squared. In that case, we shall replace, that is x squared plus y squared is equal to r squared will be 5. Then if you take 5 as r, you will find 5 squared, it will give you 25. So meaning the equation of that circle is going to be x squared plus y squared is equal to 25. That is how we do find the equation of that circle if the origin is 0, 0. Let's see another example. We have been told that line AB is a diameter of a circle such that the coordinates of A and B are -1, 1, 5, 1 respectively. Determine the center and the radius of that circle. So the first thing, I shall draw that diameter. Now after finding that, we need now to construct, this is our circle, so we are going to give them the coordinates, that is A equals to -1, 1, and this one is 5, 1. That's at the coordinate, and this is B. So if this is the center, let's assign center as O. We can find the radius of the center, and we know the radius there. Radius is always diameter divided by 2. So meaning that if we need the radius, we shall take the x coordinate of A, we add to x coordinate of B, then we divide by 2. And if we do that, whatever we shall be finding is the x coordinate at the center of that line. So in that case, it will be -1 plus 5 divided by 2, and this is 4 over 2, you will get is 2. So the y coordinate now will be y1 of A, that is y of A plus y of B, divided by 2, which will give you 1 plus 1 divided by 2, and you're going to get, this is 2 over 2, and it will still give you 1. So that is what we have there. So meaning that the center of that circle is 2, 1. So here we shall have 2, 1. That is what we have. And if we want, for example, we have been asked to find the radius. The radius of that circle can still be determined by taking the magnitude of the length. That is either OB or AO. So we can determine the radius in any way. So I suggest that we take OB. So if we take OB, then the length of that OB will be equal to the radius. The length of OB is equal to the radius. So if that is the case, we shall find OB, and we know for finding OB is the same as taking B minus A. That's the modulus, and that is the same as we are going to find the modulus of B. We are having B is 5, actually it's 5, 1, and B is 5, 1. I'm just fast calculating B. 5, 1, that is written in column vector, and O is 2, 1, so we shall subtract 2, 1, and we're going to find that it will be in point of 3, 0. So that is what we are finding if we take B minus A. But remember, if you want B minus O, sorry for that. So remember one thing, that if you are finding the modulus of OB, then it means we want to find the magnitude of that OB, and it will be the length. So that is the radius. So OB modulus is the same as we are going to find, because it is in 2 dimensions, it will be x squared plus y squared, the square root. So that one, if we do that, we are going to find R. This one here is going to give us the coordinates. The coefficient of x here we are having is 3, and the coefficient of y is 0. So we shall have our answers. 3 squared is equal to 9. Square root of 9 you will get is 3. So meaning that the radius of that circle is 3 units. The same, if you work with the other method, you will find that if you take AO as the radius of the circle, then it will be O minus A, and that is 2 minus 1, you will get 3, and 1 minus 1, you will get 0. So it's still the same, 3, 0. Then you find the magnitude of O, and you will find it will still give you the radius as 3. So we have found the radius of the circle is 3. So we were told also find the equation of the circle. To find the equation of the circle, we shall introduce another point on the circle such that that point be like P and have coordinate x, y, which are unknown. Now to find the equation of that circle in that dimension, we shall say, if it is in 2 dimensions, we did say, we shall take x squared plus y squared is equal to r squared. And now we are having x squared plus y squared. And since here we are having the center being 2, 1, then it means what we shall do here will change. It will not be that. We are going to take, since we had 2 formulas, if the center is 0, 0, then you will use that formula x squared plus y squared equals to 0. But if the center has some values inside, that's numbers like this, we said we shall use a formula of x minus a squared plus y minus b squared is equal to r squared. In that case, we shall have x minus a, and our a here is the coefficient of x in this coordinate O, so it will be 2. Because it is positive, it shall maintain the sign negative there. Then plus y minus, because it's positive 1, it shall maintain the sign negative. So we shall have r, we got r is 3 units, so it will be 3 squared. If you do that, you are going to get this one, you should square them again. So you are going to get, this one will give you, you can leave that way or you expand. So if you expand, you are going to get x squared minus 4x plus 2 plus 4 plus y squared minus y 2y plus 1 is equal to 9. So you connect the like terms, and if you connect, you will have x squared minus 4x plus y squared minus 2y. Now this is 4 plus 1, you will get 5. If you subtract 5 from both sides, you will find that you are going to have is equal to 9 minus 5, you will get 4. So that is what we shall have as the equation of that circle. You may decide to bring this side to the left hand side to have subtract 4 equals to 0, or leave it that way. That is the equation of that given circle. So that is how we do find, in case you have been given the coordinates of the diameter of that circle. You first find the midpoint of the circle, that is the center of the circle. After that you find the radius, and then you introduce another point with the x and y coordinate. From there, then you find the equation of the circle using that. The equation of a circle is given by x squared minus 6x plus y squared plus 4y minus 3 equals to 0. Determine the center and the radius of the circle. So if you have been told to determine the center and the radius of the circle here, that one doesn't require even drawing. It's a theoretical knowledge whereby we have been given equation as x squared minus 6x plus y squared plus 4y minus 3 equals to 0. This one, I will show you a quicker method of working it out. And the quickest method is that we shall first take those which are of quadratic equation in one side, and these constants will take it to the other side, so that we may complete it using completing square method or completing the square method. So if that is the case, then we shall have the left hand side at x squared minus 6x plus y squared plus 4y is equal to, subtract, add 3 to both sides, you will get, this one will eliminate itself, and that this other side will be positive 3. So if that is the case, now we are having two quadratic expressions on the left hand side. So we shall complete them to make them be a complete quadratic equation, or we say we complete the square. And if that is the case, remember we said we shall introduce c, and in order to get that c, we say that c is equal to b over 2 if the coefficient of x squared is equal to 1, then we square. So if that is the case, we shall have for this x, we going to have for x will be negative 6 over 2, then we square. And for y, we shall have positive 4 over 2, then we square. So that is how we shall be finding the c in both sides. So after doing that, we shall have this one will give us negative 3, but in negative 3 squared we will get positive 9. So we shall have here it will be x squared. So we shall replace as it is. So it will be minus 6x minus 3 squared plus y squared plus 4y. Then this one will give you 2. So you add 2 squared. But remember what we said earlier in quadratic expression, that was topic 1. We did say that if you work out on the left hand side, in order to maintain the equation to be uniform, then whatever you do on the left hand side, you should do on the right hand side. So meaning, whatever we did here, we should do also on the right hand side. So we shall also add the coefficients of c on the right hand side, both of x and y. So if that is the case, we saw earlier that this one here can compress itself or factor out to give us one equation, that is x minus 3 squared. In case you expand this, you will get the equation here, then plus this one here will give us y plus 2 squared, and this one here will go on and give us, this is 3, negative 3 squared will get 9, positive 2 squared is 4, so you are going to have 9 by 4 by 3. So 9 by 4 is 36, then take that 36, you multiply by 3, you're going to get 108. You'll get 108. So after getting that, we know this one here now resembles an equation of a circle with the center AB. So we are going to have, it is resembling a center, equation of the circle with this kind of equation. So that is, so meaning this is r squared, and here we have a and b as the coordinates. So we can say the value of a is 3. It will be positive 3, not negative 3. So it will be positive 3. A is equals to positive 3, and b equals to negative. Because it is positive, if you take it out, then it will be negative 2. The reason being that in when we are substituting the equation of the circle, we saw how we find the length of that given interval between x and the center. So we do subtract in order to get it. So if you find it positive, then we do add. So for the case when it is positive for this, then it means the coordinate of the center is negative. So that is how we shall find. So meaning that if we need to give the coordinates of the center, which is O, then we shall give it as 3, negative 2, which this is in position of A and B. So that is the center, and the radius here will be equal to square root of what we have here is 108, and on doing that you can even simplify it further and say it is 36, square root of 36 multiplied by 3, and this one will give you 6 root of 3. So that is what you are going to have. That is the radius, and this is the center of that circle. With that, we have come to an end of graphical methods. This one, I told you, you can calculate equation of a circle. You can either use a graph or use a plain space as this. It will still give you the same idea, so long as you understand whatever you are working on. With that, we have come to the end of our topic. I hope it has been interesting. Thank you for watching it. See you in our next video.